Good day. My name is Tashna Lumsden, and this is my application to the e-Biomes Ocean Engineering Robot Competition, where I am presenting my project, the Cargo Bass. As a camper of the e-Biome Summer of STEM, I engaged myself in the Ocean Engineering Robot Design Competition, where, as campers, we were required to design an underwater vehicle. Therefore, I decided to design a remotely operated vehicle, otherwise known as an ROV. ROVs are remotely operated vehicles that allows us to explore the ocean without actually being in it. They are unoccupied, highly maneuvered underwater machines that are connected to a surface vessel using a joystick. This is connected through a group of tethers to the ship using electrical signals that are sent back and forth between the operator and the vehicle. This describes the main function or operation of an ROV. However, my ROV, the cargo bus, has a unique added function. This function will be described further. The project is aimed to construct a unique design of an ROV which will have the ability to retrieve items in water. This is the primary function of my RV, the cargo bus. To do this, the design was made with the ability to dive, drift, glide, or accelerate through water with a cargo net basket that is attached to the main frame of the ROV. The cargo nets of the cargo nets of this ROV includes a card that is around the ring of the opening of the basket that is attached to a spool mechanism. The purpose of the mechanism is to reel in cards that are wrapped around the opening of the basket whenever the item that is said to be retrieved is inside of the basket. Once the item is inside of the basket, the operator will use the joystick or the controller to power power up the spool mechanism for it to rotate the cards and tighten the basket or the ring around the basket so that when the ROV is coming back up to surface, it does the item get does not escapes the basket. More about the cargo bus. The cargo bus includes an endoscope camera, which is used to capture footage while underwater. This will especially aid in the navigation of the ROV under the water while it is going towards the item that it is set to retrieve. Next, you have two thrusters that are in the middle frame of the ROV, as well as two that are at the side of the frame of the ROV, which gives the ROV enough power to travel throughout the water. I ensure to give it four thrusters because my ROV will be traveling with added weight after it has retrieved or collected the item. Therefore, I made sure that it has enough power or thrusters to travel back to surface. Next is the spool mechanism. The spool mechanism is powered by a motor. This motor is controlled from the remote, as I said earlier. The motor is connected to an axle. The the axle uses gears and roller chains to ensure that the spool of the ROV is rotating correctly so that the treads of the ROV not treads so that the cord of the ROV that is supposed to tighten the basket can be tightened. Lastly, LED lights were placed in the acrylic glass PVC pipes to ensure that we are, well, I am using enough space that are accommodated by the ROV. This also avoids added weight being onto the ROV, and it adds aesthetic to the design. Materials used. For this design, I used 12 90-degree connector pipes and 8 T connector pipes. I used 4 to 4 inches of cords and 18 cable ties, two 100 centimeter long PVC pipes with a diameter of 2 centimeters, and one 20 by 2 acrylic PVC pipe that is 10 centimeters, no, that is 100 centimeters long, and also 1 yard of cargo net material. Here is the left view of the ROV, where you can see the dimensions for the ROV, and as well as notes. The note says that the dimensions are in centimeters. Here is the front view of the ROV. From the front view, you can see that I stated that there are four the cob LED strip lights. These strip lights will be placed in the acrylic glass PVC pipes so that we don't have to add, so that I didn't have to add any extra flashlights, as I said earlier. Next, you have I labeled the acrylic PVC pipes. I also labeled the camera. I labeled the cargo net basket that is underneath. So this is the front view of the cargo bus. Here's a top view. On your left, you can see the thrusters, the cable ties that are attaching the added pipe that is added for buoyancy. You can see the spool. There are labeled spool details. We'll get to that further. And then over the right, you can see that is the bottom of the cargo net basket. There's the PVC pipe and the cargo and the cable ties that attaches the cargo net materials onto the pipes. Next, we have our spool details. So for the spool, you have your axle for the spool. There, I have labeled the gears and the roller chains that are attached to the motor, and the motor allows for for the axle of the spool to rotate in order to retrieve the cord that is around the opening of the basket in order to tighten the basket's opening. Beneath that, there are I labeled cable ties. So the cable ties will be wrapped around. There will be an opening for the. There will be enough space for the cable ties to be wrapped onto the cargo net that is beneath it, so that it can have enough sturdiness for its function. This wraps up the end of my presentation of my ROV. I really do hope that this presentation or application pleases you and that my ideas were easy enough for you to digest and that my application will be successful. Thank you.